Okay, good morning class. So at this point we're looking at exponents and we're looking at the examples for exercise 2.2 and the examples for exercise 2.2 is basically on page 42, however the examples are on page 41. Okay. So applying the laws of exponents. So the first sum says you need to simplify. You got 4a squared times 2a4. Okay, so that would simply give us 4 times 2 is 8a. A squared times a4. A to the exponent. Okay. Look at the next one. 2x cubed times 6x squared. 2 times 6 is 12 x 5. Remember what is the rule when we're multiplying and bases are the same way? Add the exponents. Is there any confusion here? No. Okay, don't tell me later on, okay, I didn't understand anything. No? Here's the next one. We got 3 multiplied by 2 squared multiplied by 3 to the exponent 5 divided by or over 3x to the negative 3 times 2 squared times 3 to the exponent 9. So when we're multiplying and bases are the same, what do you do to the exponents? We add the exponents. Not so. So it's going to simply be 3. There's no exponent there, there's a 1. Not so. So it's 1 plus 5. Okay. When we multiply and bases are the same, we add the exponents. When we divide and bases are the same, subtract the exponents. So it must be minus 3. Becomes plus 3. And minus 9. You guys understand? There's no sign here, so if there's no sign, the sign is positive. Not so? Times 2. And the 2 is being squared. And then plus minus 2. So it becomes 3. We add the exponents here. 1 plus 5 is 6 plus 3 is 9. 9 minus 9? 0. Times 2 minus 2? 0. Can I just leave it blank? No. Why not? If it's blank, then that means to say there's a 1. Okay. So because it's 0, I write a 0. People, anything to the power 0 is? 1. So it's going to be 1 times 1, which is? 1. Okay. See, any confusion there? Okay. Okay, let's look at the next one. So here we got, again to our simplify, we got 3ab to the 0c4 divided by 4ab 6c, and that's divided by 6b to the negative 4c cubed divided over 4c to the negative 1. So what do I do first? What? Tumble and times. Okay? So that is simply 3ab to the exponent 0c4 over 4ab6c times 4c minus 1 over 6b minus 4c cubed. Now what do we do? What I do is I simplify my numbers only. If you want to simplify your exponents as well, no problem with it. Okay? But what I do is I sort out my numbers first. 3 going to 3 once, 3 going to 6 twice. 4 cancels 4, not so. So I got 1 over 2. Okay. So what I do is I multiply the top out, the top exponents in the numerator, and I multiply the one in the denominator. So what is A, B, C, 4 times C to the minus 1? What would that be? A, B to the 0, which is 1, yes? And C, cubed. You all agree with that? Just multiply the bottom out. So it's A, B, 6C times B negative 4, C cubed. So multiply this out, what do I get? A, B to the exponent, 2, C, 4. This was a 1 there. Okay, you all agree with that? So what do I say now? So it will be 1 over 2. Where's there more A's? Where are there more A's? Sorry? Same. So what will happen? Cancel. Where's there more B's? Bottom. So it's B squared. Where's there more C's? So it's C is where? C1. It's absolutely correct. Not C squared. C to the exponent. Okay. Do you guys understand? There's one way of doing it. Okay. Otherwise, what I could have done was, okay, and that is the method that I'm going to apply most of the time. Otherwise, what you could have done was, you could have said, that's going to be 1 over 2. Okay? So when we're multiplying it by so the same, what do you do to the powers? You add. So that will be A1. There's no A's on top. However, I'm dividing by this A here, not so. Becomes minus 1. You will agree with that? B. Miss Hendricks? You okay, my girl? Looks like you're sleeping. Not sleeping, it just looks like. Okay. People, anything to the power 0 is 1. Or we can just say 0. When we divide, what we do to the exponents? We must minus. Can you see? So we're going to minus those exponents. So it will be 0 minus 6 plus 4. C. There's a 4 here, so it's going to be 4. So it will be plus minus 1, which is minus 1. Minus 1. Minus 3. Remember, when we're dividing, and bases are the same, subtracting. Am I moving slow enough? Okay. So it's 1 over 2. A. What's 1 minus 1? 0. B. 0 minus 6? Negative 6 plus 4? Negative 2. C. Minus 1. Not so? People, anything to the power 0 is? 1. So that is 1. Where must this one go? Bottom. Where must this one go? That would simply be give us 1 over 2b squared. Okay. And I'm sure there's more ways of doing this. Okay. See, any confusion here? The girl is tired of me already, she says. You, yes. Yes, you're so tired. Yes.
So how can you move B minus 2 and C minus 1 to the bottom?
Because they always wanted to write it in positive exponents. That's why I put it at the bottom. So the rule says if you got a to the exponent negative n, it can be written as 1 over a to the n. That's the rule, that the deduction that is made from the second order exponent. Okay. So we would always want the number to be, the exponent to be positive. Okay. But just remember that now people are going to make this mistake often. They have to say a minus 2 is now going to become 1 over 2. People, that's never the case. Okay. It's only when it's on the exponent does it become negative. Okay. Right. People, we're looking at the example still on page 41. Mathematical statement x to the exponent 5 y cubed is equal to x y raised to the exponent 5 plus 3, which is xy raised to the exponent 8. Okay, in other words, state whether the mathematical statement is true or false. It is false. You all agree with that, no?
Yes, sir.
What should it have been if I got x5 times y cubed? It should be x5 y cubed. Not so. Right. So the answer to A, I'm just going to align the board again. One day when you guys are millionaires, and you organize me a laptop and a nice smart board. Okay. I don't want money from you, I just want those two things. Okay, make my life a little easier. Okay, so the answer to A, of course, is false. Okay. B. Using the definition and the laws of exponents, provide a reason for your choice. Firstly, that is what it should be. So what is the rule? The rule says, when bases are the same, we multiply, we add the exponents. Not so. And here they are adding the exponents, but are the bases the same? No. You can only add the exponents when the bases are the same. What is the base here? X and y. So it's not the same. No? Right. So use the definition and the laws of exponents. That's the answer. The reason for your answer is when bases are the same, we multiply, we must add the exponent. Give a numerical example to motivate your answer. What does that mean? What does numerical mean? Using numbers. Using numbers to motivate your answer or to substantiate your answer. No? So let's look here. Let's say let x equal 1 and y is equal to 2. Okay. Or you could have let x equal to minus 6 and y is equal to minus 100. Whatever you want it to be. But never would we say let x equal to 1 and y is equal to 1. So then you're not going to see the change here. Okay. So we choose the values here. We could have chosen x to be 2 and y to be 3 or whatever you want it to be. Okay. So if that is the case, let's go with the left hand side of the equal sign. Okay. So if I say x, I put a 1. So I say 1 cube to the exponent 5 times 2 to the exponent 3. And 1 to the exponent 5 is 1. 2 cube is 8. And 1 times 8 is 8. So let's check the right hand side. So if the answer is 8, most likely it will be correct. No? Not 8 and then not correct. So this will be x. So it's 1 times 2 raised to the exponent 5 plus 3, which is 8. So it's 2 to the 8 and 2 to the exponent 8 is 5, not 5, 1, 2, 2, 5, 6. 256. People, is 8 the same as 256? So we say, since the right hand side is not equal to the left hand side, therefore, statement is false, or we are good. Okay, the statement is false. Alright, any questions there? No. Let's look at the next example. So here we are given So here we got the answer simplified. We got 2a squared raised to the power 2 minus 2a raised to the exponent 4. So what do we do first here? We need to apply the exponents on this bracket here, not so. So there is a 1 here, so it will be 2 to the exponent 2, 1 times 2 is 2, a to the exponent 4 minus, there's a 1 here, so it's 2 to the exponent 4, a to the exponent 4. So what's 2 to the exponent 4? So it's 4a4 minus 16a4. You all agree with that? Okay. And what is 4a to the exponent 4 minus 16a to the exponent 4? Negative 12a to the exponent. Any problems there? Next question. Again, they asked to simplify. Got 4a to the exponent 3 plus 6 squared a cubed. Get rid of the brackets first. Okay, so this is going to be 4 to the exponent 3, because that is a 1 and a 1, so it's 4 cubed a cubed plus 6 squared a cubed. What's 4 cubed? 4 times 4 times 4, which is 64. A cubed plus 36 a cubed. So that's going to give us 100 a cubed. Well, why not 100 a 6? We multiply, we add. When we add and subtracting, the variables say the same. Right. So with that, you should be able to do exercise 2.2. Right. At this point, we'll stop the video.